screen because I need to switch back and forth. So is this okay?
Yep, perfect. All right, thank you. Hello everyone, welcome back. I'm Fiona, who is the host for the remaining 2 sessions of the day. Now let's welcome our next speaker, Daniel Lee. Daniel will cover the topic of building a self-service internal developer platform with CDK for Terraform and TypeScript. Daniel has been a software developer since 2013, specializing in JavaScript and DevOps. He is the author of Building Enterprise JavaScript Applications, PATS, and an upcoming live project series, Manning, titled Internal Developer Platform on AWS. Daniel currently is a staff software engineer at a London-based company, Zinc. Welcome again, Daniel. May I pass the turn to you?
Thank you, Fiona. Thank you for coming to my talk. It's called, as Fiona said, Building a Self-Service Internal Developer Platform, or IDP with CDK for Terraform and TypeScript. It's quite a long title. You might not understand what everything means right now, but that's the whole point of the talk. At the end of the talk, you should be able to understand everything. You can find me on LinkedIn and Twitter with the handle D4NYLL. Just a little bit more about myself that Fiona didn't cover already. I see myself as a generalist. I've worked professionally on the front end, the back end, and also DevOps. And I love writing. And I've written a book on the JavaScript ecosystem called Building Enterprise JavaScript Applications. And I've also more recently written a live project with Manning called Internal Developer Platform on AWS, which I'll talk more about at the end of the talk. But this project isn't published yet. I think it's going to be published in about a month's time. But if you use the same link, you'll be able to get it once it is published. So what is an internal developer platform? An IDP is a self-service, on-demand platform for software developers to provision ephemeral production-like environments. Again, if this doesn't mean anything to you right now, that's fine. Just stick around. At the end of the talk, you'll understand everything. I've broken this talk into 4 sections. The first section explains why do we need an IDP? What problem are we trying to solve? And a hint to the answer is that because developers need test environments. In the second part of the talk, I'm going to talk about possible solutions. So IDP is just one solution to providing test environments. A more established solution is to use staging environments. And I'm going to talk about where staging works well, where staging doesn't work well, and where an IDP can come in and patch up the shortcomings in staging. In the third part of the talk, I'm going to explain how you would build an IDP from scratch. It's not going to be very detailed code base. It's more going to be like a high level overview to give you a blueprint of how to build an IDP from scratch. And the tools that I've chosen to use here is CDKTF, which is Cloud Development Kit for Terraform, a node-based API, I'm going to use Express, and for the web-based UI, I've used React. And I only have 25 minutes here, so I couldn't cover too much stuff. And so in the 4th section, I'm going to talk about, let's say you have built a rudimentary IDP, what other features can you look into implementing to make it more production ready? So let's dive into the first section, which is why do we need an IDP and what problem is it trying to solve? So fundamentally, the problem we're trying to solve is that developers want confidence that their code works. And this is typically done by writing tests. So you have the automated unit integration and end-to-end test, and you also have the manual exploratory test. So the automated test tests for known issues, and the exploratory test tests for unknown issues. And to run these tests, developers need test environments. So for the automated test, you can run the test in Jenkins or like Circle CI or Travis. But for exploratory tests, you really need to deploy the application or the API and provide it to developers or like other people in your team for them to play around, poke around, trying to find issues that wasn't uncovered earlier. So typically, traditionally, to do that, the development team would have to create a ticket for the operations team to say, please, can I have this environment? I want to test this change. And then people have to wait a few hours, maybe a few days for the operations team to have some bandwidth to create the environment. And then once the environment is not needed anymore, they have to create another ticket or update the existing ticket to say, can you please destroy this environment? So as you can see, like there's a lot of friction there, a lot of waiting around. So it's not ideal. And this is one of the problems that an IDP can solve. But like I said earlier, an IDP is not the only solution to providing a testing environment. Traditionally, people have been using staging environments as the testing environment. So let's talk about staging a little bit. Staging is a permanent test environment that mimics production as closely as practical. So in theory, staging should have a similar scale to production, same number of servers, same number of load balancers, same number, the same type of network configuration. Any libraries that have been installed in production should also be installed in staging, et cetera, et cetera. So the promise of staging is that because it mimics production as closely as practical, then anything that works in staging should also work in production. And when implemented correctly, staging does live up to its promises. But implementing staging well is hard. I don't do it properly. So for example, like instead of deploying 5 replicas, they may just deploy 1, and maybe the problem doesn't surface unless you have, let's say, 3 or more replicas. So staging can often become a source of frustration, up to the point where people are so frustrated with staging that they just get rid of it altogether. But even if you do implement staging well, if staging is your only test environment, it can still lead to 3 issues. So the first issue is configuration drift. So in theory, any changes that you apply to staging should also be applied to production and vice versa. But in practice, this often doesn't happen. Let's say I'm deploying a build on staging and it fails. Obviously, I'm not going to do the same thing in production, but maybe I forget to clean up after myself. And there may be some artifacts that's left behind from the failed build that I forgot to clean up. And so these small changes build up over time. So maybe in a few weeks' time or a few months' time, staging can no longer be considered a faithful reproduction of production. And so when I deploy something on staging and it works, but when I deploy it on production, it may not work anymore. The second issue is cost. If staging is supposed to be a replica of production, it needs to be of a similar scale. And so it means running staging costs almost as much as running production. And obviously production provides business with value, but staging, when it's not utilized, it's just sitting idle, accruing costs, but not providing any business value. On the other end, if staging is overutilized, you end up with bottlenecks and queues. So if there's only one staging environment, there's multiple teams, they all want to test the changes, and someone has to coordinate between the different teams to see who can use staging. And so there is a coordination cost, as well as like people waiting around, not being able to test and deploy the changes. So an IDP can come in to patch up the shortcomings of staging. And let's go through the definition again to see how we can do that. So let's focus first on the on-demand property of an IDP. On-demand means developers can create environments as and when it's needed. So this can tackle the configuration drift problem with staging, because if developers want to change something about environment, they no longer have to go into the server, run git pull, and then run a redeployment. Instead, they can just simply destroy the old environment and create a new one because it's on demand, because you can create it as and when you need it. The second property of an IDP is that it's ephemeral. So it means that if I create an environment to test my changes, after I've tested my changes, I don't want it anymore, I can just destroy it. It's not a permanent environment. You create it when you need it, you destroy it when you don't need it. The third one, which I think is the most important, is that an IDP provides self-service to developers. So instead of creating a Jira ticket, someone having to read the ticket and action on it, we can provide a web-based user interface or a command line user interface where developers can use to create these environments, again, on demand, but without human interaction, basically. So, and then an analogy I like to give for the self-service section is that imagine you're in a packed restaurant and using staging is like having a single waiter or waitress. You have to wait for the waiter or waitress to become available for them to serve you the food. Whereas if an IDP is more like, again, a packed restaurant, but you have a little iPad on your table where you can order whatever food you want at any time you want. So I hope this gives you a bit more context about what an IDP is, but I appreciate that it's still a bit abstract. So let's go through a more concrete example. And so in this scenario, we have an application. It really doesn't matter what the application is. In this case, it's just a API that has a long list of pet names. And when you hit an endpoint, it will pick a random name from the list and return it as the response. So this is what it will look like if you run it. I'm curling it 10 times and it's giving me 10 names. Very simple app. So in this scenario, a developer has made a change. He wants all the names to be French names, and he wants to be able to test this change in a test environment. So how would he do that with an IDP? So this is an IDP I built earlier. What he will have to do is create a unique name for the environment, and then select the application that he wants to deploy. In this case, it's called Pet App, and then needs to provide some configuration values. For example, the branch to deploy. So he's using the web UI, is filling in a form, click the button, and now in the background, the resources, the infrastructure resources is being created. But all that is abstracted away. So it takes a while because it's actual infrastructure resources being created. So you have, for example, like a server, a load balancer that's being created in the background. And once it's deployed, important information is printed on the IDP itself. So for example, in this case, we care about the load balancer DNS name because that's the endpoint of the API we want to hit. So if we do copy this DNS name and we curl it, you can see that the changes have been applied. All the names that's returned now is all French names. So a developer wanted to make a change, they want to test the change. We've now created an environment, and now we've tested on that environment and it's working. So we don't need the environment anymore, so we can just destroy it now. And destroying it is just as easy. You click a single destroy button, and after a while, it'll be marked for destruction. And once it's destroyed, again, it will take a while because it's actual infrastructure resources being destroyed. So after a while, about 2 minutes, it's removed from the user interface. So the value of an IDP is that it abstracts away the infrastructure resources so that if someone wants to deploy an environment, they can just click a few buttons and fill in a few forms. So at this point, if you're thinking, oh, that's great, I want to create test environments using a web user interface, how would I actually build an IDP? So the first step is to use infrastructure as code. So for me to be able to fulfill the self-service requirement of an IDP, I need to be able to define and deploy infrastructure for my environment programmatically and dynamically. And that means you need to have a way to do it automatically. So an infrastructure as code tool allows you to define your infrastructure as code and use the tool to read that code to deploy and then talk to the AWS API to create these resources for you automatically. So for example, our pet app environment may consist of these components. So we have an ECS service, which actually runs the application. We have an ECR repository that stores the Docker image for the service. And we also have a code build project that listens for changes in the GitHub repository, build the image, and then redeploy the ECS service. So the little environment for our pet app consists of these components. And we can define each of these as code. So for example, the ECR repository, we can define it using these 4 lines of TypeScript. This is the CDKTF code in TypeScript. And for the ECS service, we can define it using a few more lines of code. And just as with any other infrastructure as code tools, there's a bit of boilerplate. So if we define our components using CDKTF, add a bit of boilerplate, we can then run the CDKTF deploy command, which is a CLI tool. It will read those code, the TypeScript code that we've written. It will figure out what resources that we're actually asking it to create. And then it will interface with the AWS API to actually create those resources. And so by using an IAC tool like CDKTF, we have added a layer of abstraction on top of directly calling the AWS API to create those resources. But this is just one step to creating IDP because someone still has to write those TypeScript code and someone still has to run the CLI commands. So how can we abstract it even further to make it more accessible to more people? So the next step is to create an API with an endpoint that people can call to create these environments. And so everything we did in the last section, we can automate it in the handler of the endpoint. So I've broken it into 4 parts. So the first part, we actually automatically generate the code snippet that we would have added ourselves manually to the CDKTF project. It defines all the infrastructure that we want to build for that environment. And then we add it to our project code. And then we commit and we push it to a remote Git repository to persist the change. And then we use here the child process API from Node.js to run the CLI command, the CDKTF deploy command. And so if we create this API abstraction, then now to create an environment, people don't have to call the AWS API, they can call an API endpoint. But still, this is not super accessible because many people are not familiar with calling APIs or using the terminal. For example, think about a salesperson. If they want to create a clean environment to demo the application to potential clients, they don't want to use staging, they don't want to use development because it may be broken, someone else may be using it, and they obviously don't want to use production in case they break something. So they want to create a fresh environment for to demo to the potential clients, and asking them to run a CLI command or like hit an API endpoint maybe beyond their capabilities. So how can we make it even more accessible to everyone in the team? And that's to create a web-based UI. So in this example, I have created a React component that has a form that when I submit it, sends a request to the endpoint I created in the last step. But you don't have to use React, you don't have to use even any frameworks. All you really need is a form and a way to submit that form. So this is the form that I showed you earlier. And if you follow this, then now you can create a set of AWS resources that constitute your environment, not by calling the API, but with just a few clicks of the button and filling in some forms. So if you do want to build an IDP from scratch, this is the blueprint you can follow. Define your infrastructure for your environment as code. You can use CDKTF as I've shown here, but you can also use other tools like Terraform or Pulumi. And then you abstract that away with an API that creates the infrastructure as code programmatically, and then runs the IAC tool programmatically as well. And then to top it off, you want to create a web-based UI or a command line interface that will call the API on your behalf. So if you follow these steps, you will have an IDP. So let's go back to the previous example with the context that we have now to see, again, what's happening behind the scenes. So again, I fill in the form. I want to create an environment to test my pet app. The API receives the information, created the code snippet, and committed it, pushed it to GitHub. And now it's running the CDKTF command to actualize the resources that I want to create. And it's running Terraform in the background. Basically, with any IAC tool, what it does is it tries to reconcile the desired state, which is I want this environment to exist, and the current state, which is like this environment doesn't exist. And we'll try to see what actions it can take to create this environment. So in this case, the tool concluded that it needs to create 16 AWS resources for this environment to exist. So in the background is creating this resources. Again, it takes a while because it's actual load balancers, actual ECR repositories being created. So in this case, I think it takes about 2 or 3 minutes. Once all the resources are created, then you can see that it's updated on the front end. It says it's deployed. And then a similar thing happens when you try to destroy an environment. You click destroy, the API receives the request, generates a code snippet, removes it this time from the project code, and it runs Terraform. And this time, because we want to remove the environment, it needs to destroy some resources. And again, it takes a while. And after everything has been destroyed, the environment is removed from the platform interface. So just to put it into a bit more context, where does an IDP fit in? So we talk a lot about DevOps, but we talk about it as if it's one thing, but there's actually many different topologies in which devs and ops can work together. So an IDP is one of the ways in which it can facilitate dev and ops working together. So in this, if you use an IDP, the operations team have to write some code to create the platform, but then the devs can then use that platform to carry out traditionally operations tasks. And I want to reiterate the point that an IDP and a staging are not exclusive to each other. They're complementary to each other. There are some tests, there's some errors and bugs that only surface when you have a permanent environment. For example, memory leaks may only surface if the environment is long running. So you environments like with an IDP. So you need staging and you need IDP. They are complementary to each other. So going further, let's say you have built an IDP what other features are commonly found in a more like production-ready IDP. One of the features is automated teardowns. So you don't want the situation where someone creates an environment, goes off on holiday, and leaves it there for 1 month, not being used, because that will accrue cost and it's not bringing any business value. So you can implement an automated teardown or time to live, so that every environment by default have a certain lifetime, let's say for a day. So if you do not manually extend the lifetime of that environment, it will be automatically destroyed after a day. Another feature you can look into implementing is notifications. Once the environment is ready, you can notify the developer, or if a deployment fails, you can notify the operations team. In this case, in the example that I've given, it's quite a simple environment with a few components. But in a real world scenario, you have many components, you have databases, you may have to run migrations, you may have to input dummy data. So it can take a while for environments to be ready, and you don't want someone to always come back to the IDP to poll it to see if it's ready. So you can send them a Slack message or an email once it's ready. So that would be a better user experience. Another thing you can do is to automatically trigger tests. For example, you can run smoke tests as soon as a environment is ready to make sure that it's actually functional, nothing has failed. And then the fourth feature you can look into implementing is authentication and authorization. Basically, this allows operations to know at any time who owns an environment. So if an environment has been running for like 7 days, you can ask them like, why is it running for 7 days? Do you still need it? And it can also prevent other users from deleting someone else's environment. So it's 26 minutes now, but I couldn't cover too detail of how to actually write the code to implement a IDP. But if that's something you want to do, I have created a live project series with Manning where I'll give you like a step-by-step guide on TypeScript. You learn about Terraform, you learn about CDKTF, you learn how to implement a authentication and authorization layer with Passport JS. You learn how to use cost allocation tabs on AWS to implement cost management. You learn about AWS organizations. It's a lot more material there than what I covered today. And more importantly, you get access to the source code. So if you like the IDP that I've demoed, you can have the source code to that application if you join this course. And if you buy the whole series, which you can show on your CV or social media. So this link is not currently working because it's not published right now. It's going to be published in about a month's time. So bookmark the link and come back to it in a month's time and you can enroll into the course. So with that promotion over, this is the end of the talk. So I'll open it up to the audience for questions now.
Thank you, Daniel.
Daniel, so that since the publication is not ready, you may ping me when you release the application, and we can share in the social media.